Welcome to XSS tutorial number 6, bypassing advanced filters and protecting against cross-site scripts. In this video, we'll be looking at evading some more advanced XSS filters. We'll also look at protecting our websites against cross-site scripting attacks with the use of HTML entities and content security policies. Every video will have all slideshows and code available in the description. Generally, if you make it to this point and need to start encoding your attacks, it's pretty likely that the defenses have been implemented well. However, it's best to at least give these techniques a go, as not all filters are made the same. You may be able to just squeeze through with an encoded attack. Let's just quickly describe two places you can do sanitizing. First, on the inbound. This is before you touch or do anything with the inputted data or information. You sanitize it before you place it into your database or before you do any calculating. This is where you make sure your server and site is safe from attacks like SQL injection, remote file inclusion, etc. Then there's outbound. This is where you want to sanitize any data that we are sending out to the users. We protect the users of our site here. We want to make sure that any possibly exploited sections of our site that may have gotten past our inbound defenses are nullified before sending it to the users. Alright, let's look at the method that will most likely work if you're not having much luck. So here we can see what looks like a bunch of gibberish. However, this is just a string written with HTML entities for each character in decimal ASCII. These entities will form our familiar JavaScript::alert XSS after the web browser evaluates their characters. This is great for bypassing blacklists and strong quote filters. This is also great for hiding the purpose of a reflected attack. We can do the same thing with hexadecimal as we could with decimal. It will turn into our same JavaScript::alert XSS. There is plenty of text to hex and text to decimal converters on the web. Google and find one you like. Looking into HTML entities is also a great idea. Okay, let's give this encoding attack a shot. Grab an ASCII converter or just copy the code from the code.txt file to save yourself the pain of typing it out. The new web page now has a simple blacklist setup to stop you from using the script tags or the alert word. Alright, so let's jump over to our web browser here and we're going to try our link that's going to be encoded. So I'm going to copy and paste it in here. So it's just a standard A tag with a href, and that href has all of our encoded characters, which will be equivalent to JavaScript::alert XSS. We just have this link saying click me, and then we close off our A tag. So if we click comment, it'll go through and we get our click me here. If I hover over it, down the bottom you'll see in the bottom left JavaScript::alert XSS. So we click it, we get our XSS pop up. Cool. So it's just that simple. Alright. If you believe that it's possible that the target website has only inbound filters on GET requests, you can try and slip by with encoding your URL GET variable You can try and slip by with encoding the URL GET variable info in hex. For example, here we have the script tags and the alert XSS encoded. Let's give this a quick shot. So if we jump back over to our web browser and we grab our URL encoded string, so I've got it copied, and we've got this get our name area which we've used before, and we can come up to the top here and we can put in our encoded string. So it's all these percentage and then hex values, and if we hit go, we get our pop-up of XSS, and you can see after it's been translated it comes out as script alert XSS and then closing script. Cool. There is many one-off tricks that may work against certain filters in certain browsers. I suggest looking at the OWASP's filter evasion cheat sheet for an idea about how they work. My favorite is a malformed script tag that will pass a lot of blacklist filters but still execute in browsers that ignore unknown characters in known tags. You may also notice that the script file that is linked to has an image extension. If you rename a JavaScript file, the web browser will still try to execute the file as JavaScript no matter what extension it has. I've set up a second page which you can navigate to by clicking on the next link at the bottom of the test page. The page has no blacklist, no specific filter except for the HTML entities function that turns all characters with meaning into a HTML equivalent. Can you manage to get an XSS attack through? Leave your results in the comments. Okay, let's talk about the important point to this whole series: how to protect your website. There are several measures we can put in place to protect yourself and your customers against cross-site scripting attacks. The first and probably strongest line of defense against cross-site scripting is making sure that every untrusted variable that is echoed out to the web page is encoded with HTML entities. PHP has the HTML entities function. Other languages will have something similar or along the lines of HTML encode. Now this is a good start and will prevent most basic forms of XSS attacks. The second thing we need to do is find a pre-tested library or code snippet that sanitizes the JavaScript colon from URIs. Keep in mind that if you write this yourself, that word JavaScript in the address bar scripts is not case sensitive, so it could be possible for a capital J in the JavaScript colon to throw off a script that just looks for the lowercase JavaScript colon. Thirdly, we need to remember to sanitize inbound as well as outbound. SQL injection is still a huge problem. Your protection against SQL injection may even stop a few sneaky cross-site scripts from making it into your database. If something malicious makes it into your database, it may not be a problem until the day you forget to sanitize your output when you're testing a new page or section of your site. And we can't miss content security policies, or CSPs. This is a relatively new feature for the web. CSPs is great for a very strong line of defense. CSPs are rules that your server will send in the header of every response. CSPs allow use to specify exactly what sources are trusted and to disable any inline resources that we don't want being run. I highly recommend reading about CSPs. HTML5 Rocks has a great write-up about the Content Security Policy Standard. Alright, finally a few really useful resources. If you really want to get into cross-site scripting or protecting against it, check out these sites. All the links will be in the description. Alright, the next thing that we'll be looking at is the magnificent and beautiful cross-site script that hit Twitter in mid-2014. If you have any questions, leave it in the comments and I'll try to answer it as best as possible. Don't forget to subscribe. Thanks for watching.